Hi everyone, thanks for joining me here. I'm Yevgeny Pats, CEO at Cloud Query, and in this short session I'll talk about cloud infrastructure security, visibility, and cost optimization. So before we dive in, quickly about myself. I'm the co-founder and CEO at Cloud Query. Before that, I was the founder of Fuzzy.dev, which is now part of GitLab, which is a CI for fuzz testing. Last 10 plus years I worked in the cybersecurity space, and the last 2 years I was focused in the DevX Conf space. I'm a big believer in this space as a developer myself, and before that I served at the cybersecurity intelligence unit. So let's dive in and start with a question. So why do we need another security tool? And because we are at the DevX Conf, I'll reuse the meme from the manifesto and transfer this. I need to walk you through a small exercise. So let's design a small to-do app in AWS and sign up, which has two main features: sign up and log in users, and each user can add, remove, update his own to-dos. So it's a classic multi-tenant application. So we have our users, we hire our first Ninja developer, he goes, opens an AWS root account, he creates an AWS IAM user for himself, he enables MFA, creates an access key. Now he stores the front-end application as S3 bucket. He uses Cognitive for authentication. The front-end application talks to the API gateway, and we want to run our business logic and prod logic somewhere, so we'll use kind of serverless architecture, so we'll run it in a Lambda function. And we need somewhere to store our to-dos, so we store it in DynamoDB. We might also want to put it in a VPC for security purposes, and we might also want to enable some monitoring, so we enable CloudWatch. So hopefully now we have something that is working to the application, but now our developer also wants to have a kind of a staging or testing environment, so we duplicate it again. And now our app grows in popularity, and we hire our first account executive. We provide him an AWS IAM user and an access key. And you might want to duplicate it again to have a demo account. So pretty quickly, you can see that it becomes this. And this is not even for a real application. Obviously, even for a small startup that has a real production application, and obviously for medium size and large organization, it is even worse. And we don't want to be this person. So we need to ask ourselves a couple of questions. So how do we ensure security, compliance, cost? How do we monitor all of this? How do we connect the dots? How do we do one-time audit or cloud infrastructure? And even better, how do we run those audits continuously so we can catch it right away when something is wrong? Some companies use multiple cloud providers. Some of them use multiple SaaS applications that are connected to those cloud providers in various ways, like Auth0, Okta, and so on. So how do we enforce policies across providers? Do we use multiple tools? How do we connect them, and so on. And this is exactly why we introduced Cloud Query. It's hosted on github.com/cloudquery/cloudquery. And in one sentence, what it does, it transforms your cloud infrastructure and SaaS application configuration to SQL for security reason, compliance, cost, and various other use cases you can think of. You can think of it as a single pane of glass for your infrastructure. We released it late last year. We already have more than 1.4K stars, thanks to all the community and the users that were opening issues, asking for feature requests, reporting bugs. It really helped a lot. It's written in Go. It's one binary. It has pluggable architecture. So actually you can write your own providers. You can maintain it yourself in your own GitHub repository. So you don't need to go through our PR process, and you can still use Cloud Query SDK and the Cloud Query ecosystem. So currently we maintain GCP, Azure, AWS, Kubernetes, and Okta provider. We are working on some more, and also we are expanding the existing providers. Obviously, all of them are open source, so you can actually add support for more resources that you need just by opening a pull request. And if some of you are familiar with Aws Query and Terraform, so you can think of it as a kind of a merge between the two tools. So enough talking, and now let's deep dive into a live demo. So first, let's start by installing Cloud Query by running brew install cloud query /tab/cloud query if you're on Mac, of course. You can also upgrade to the latest version via brew upgrade, so it's not needed currently as the latest version is installed already on my machine. If you're on Windows, Linux, you can just go to our GitHub page and get it from releases. It's precompiled binary with no dependencies, so it just works. Once it's installed, Cloud Query has three main commands: fetch, gen-config, and query. We'll go through each of them. So fetch, as the name suggests, just fetches the configuration from your cloud provider or SaaS applications concurrently. You can fetch them from multiple accounts, multiple providers, all concurrently, depending on what you specify. And to specify, you need to create a config.yaml, which is generated by a helper command called gen-config. You can pass it AWS, GCP. You can also pass multiple providers depending on what we want to fetch. So I already created a config.yaml, which we can look into. Essentially, it's a very simple YAML file specifying all the resources that you want to fetch. By default, Cloud Query gen-config generates the config.yaml with all the resources that it supports. You can comment out some of them if you're not interested, but usually it fetches them all concurrently, so it's not really a problem. Also, by default, it fetches from all the regions, but for this specific example, I'll just use uassist1. Also, another very common use case in cloud providers, that you have one role that can assume a role to multiple other accounts, and then you can fetch the data from multiple accounts with one account, one credential. So in this specific case, we'll just use the default account, but you can specify multiple accounts in this section. So now, to run Cloud Query, we also need a Postgres database where it will store the data. So you can either specify an existing database, or if you're running locally, you can run a Postgres database with Docker pretty easily. So now let's run Cloud Query fetch. It will print some logging to the screen, and it will take a few seconds, essentially creating the table and then fetching the information. So once it will finish, we'll shell into the Postgres Docker to see how the tables looks like and what we can find. So docker exec, and then we can use the psql shell. You can see all the tables that were created with /dt plus. And actually a better way, in my opinion, to see all the tables that are available in each provider, you can use schema.cloudquery.io. If you're familiar with Schema Spy, it's a pretty convenient tool to kind of browse tables that are available in the Postgres database. So you can search for GCP related tables, AWS related tables, and for each table you can see the available fields, available relations, and browse into them as well. So now let's see what fields we have at AWS S3 buckets table and create a query. So for example, we want to get all the buckets and account ID region name from AWS S3 buckets table. Now we can see all the buckets that we have in our test account. So here you can create new queries, you can investigate, you can use actually any shell that you like, not just the Postgres pSQL shell. But usually once you create those queries, some of them can be more complex than just one-liner. Some can be joins between multiple tables in the same provider, between multiple tables across providers. So you can create a query, for example, across GCP and AWS. But once you create those queries or those rules, you usually would want them to run in a CI or in some way periodically or manually together. So for this, we created something that we call Cloud Query Policy Pack. A policy pack essentially is just a YAML file with two sections, views and queries. Views is just as named, it creates a view that you can reuse later at the query section. So you don't really need to write this huge create view statements at each query. And queries, also something that we call checks, is just a name and then the SQL query. So if the SQL query returns a result, then the check fails, and you can also invert this behavior. So you can do invert false, and then if it doesn't return a result, the check will fail. So in this particular case, we actually implemented the AWS CIS benchmark. If you're familiar with it, AWS CIS benchmark is kind of a benchmark of best practices for AWS. They have the same thing for GCP, for Azure, for Kubernetes, and a bunch of other stuff. Usually it's a very long PDF with either manual steps or some shell scripts that you need to run for each and every account of yours. So what we did, we just translated it into Cloud Query Policy Pack that you can run with Cloud Query query command. And I'll show you in a second how to do that. So let's go back to our demo. Cloud Query command gets the same --dsend parameter for the Postgres and also --pass for the query policy pack. Specifically, this policy pack is available at our GitHub. So you can take it, you can customize it to your need. You can create new policy packs. You're free to share it, to open a PR and add this policy pack to our GitHub as well. So this is a very cheap command actually, because it just queries the Postgres. It doesn't go and make any API requests to the network. So you can see that we have some unconfigured security groups. We have some checks that passed, some checks that failed. We can see that we have some incorrectly configured VPCs. So this is how an output looks like. You can also put it into JSON and then kind of create alerts or monitor the output in the CI, so you know when something fails or not. So let's go back to the presentation. So what you get the most powerful query language to query your cloud infrastructure across clouds and across SaaS applications. You get open source, transparent, extensible framework. You get awesome dev community support. You can write policies with SQL. You can commit them to your repository, run it in the CI. You can reuse the SQL ecosystem to visualize your infrastructure, whatever you're using, Metabase, QuickSight, Tableau, etc. You don't need to maintain custom scripts, and you don't need to write code to run your security checks, keep up with the SDKs that change pretty often. And a bit about what next before we finish. You get support for more resources and more providers that we're currently working on. We are working on more out-of-the-box policy packs and security and compliance best practices that you can either use it as is or adopt it to your use cases. Also, we're working on a self-serve SaaS version, so stay tuned if you don't want to deploy it yourself. And also we have a bunch of more things on the roadmap, so stay tuned. And last thing, but not least, we are hiring, so jobs at cloudquery.io.